All right, good evening, pre-calculus students. It is still April 1st. No, it's not a fool. It is 11 o'clock. It's been a long day of grading your quizzes, but we're going to get this done so you have it in the morning. So as we, your quizzes were okay, but some of you guys just aren't taking advantage of your opportunities and asking questions, but now we just power on. So we're going to move on to sum and difference identities. Sum and difference meaning the addition and subtraction. So what we basically have here is 6 different identities. So it looks like it's 3, but it's actually 2, 4, 6 identities. Each one of these equations is 2 equations at once. So you have a plus sign, so this would be the sign of u plus v equals all this, and then what's on the top here. So if the plus sign's on top here, the plus sign is used here because it's on top as well. And then when you look at that, you also have the difference. So you have the sign u minus v, and so you got all this stuff, and so you would use the subtraction sign that's on the bottom. And so each one of these equations is set up as 2 different functions. So here on the cosine one, where you have u plus v, as you move through the function, you'll use the subtraction sign for the addition of cosine. And likewise, for the subtraction of cosine, you'll use the addition sign inside the formula. When you get down to the tangent formula, you've got the plus sign. So if it's u plus v, you'll use the plus sign on the top and the subtraction sign on the bottom. Whereas if it's a subtraction problem, u minus v, you'll use the minus sign on top and the plus sign on bottom. So these are going to be equations or identities that you're going to want to have written down somewhere so that when we get to our test after spring break, you'll have them and you'll be able to use them at your leisure. Something else you're going to want to have nearby, as usual, are the other identities. You want to keep these handy, as well as a good unit circle. Now, I'm going to have not so good unit circle. As we do these problems, you can probably see through the page, I have a small unit circle right there. It's not very easy to see. So the bigger, better unit circle you have probably in your notebook, the better this is going to work. So we're going to be finding exact values of angles that are not on the unit circle. So, we're going to find the cosine of 75. And so some of you guys are like, well, that's just the x value of 75. And that's true. But where is 75? 75 is about, what, here? That's about 75 degrees, somewhere around in there. Halfway between 60 and 90. Well, we don't have a value for 75 degrees. So we get to use the sum and difference identities to create that exact value. So let's get into doing that. All right, so I want to have this on here as well as working this problem down here at 75. So you're allowed to use any values along the unit circle, anywhere around the unit circle, who either add or subtract to be 75 degrees. And so I think the most obvious of those, and let's see if I can get all this on here at once, would be to use 30 and 45 degrees. Because 30 and 45 degrees add up to be 75. So that is going to look kind of like this. We're going to be doing the cosine of 45 plus 30. Okay, now you could use any values on the unit circle as long as they either add or subtract to be 75 degrees. So this was just probably the fastest, easiest way to come up with 75 degrees. All right, so from there, we work our way up to the cosine identities right here. And so we have the cosine. We have cosine of 45 plus 30. So we're using the plus sign. As we get into the formula, our middle sign will be a subtraction sign. So we'll start to put that together. Try to keep as much on here as possible. All right. So let's see. The 45 will be the U angle, and the 30 will be the V angle. So cosine of U, cosine of V, so that's cosine of 45. And this is a multiplication. This is cosine of U times cosine of V. So times cosine of 30. I'll throw a multiplication sign in there for you. And then we look, say, okay, we're doing plus on the angles. So as we come over, we use subtraction sign in between. So that is subtract. Now it changes over to sine U, sine V. So it's going to be sine of 45 degrees times the sine of 30 degrees. All right, now we read our unit circle and we calculate. So a lot of what we're doing here is just plug and chug. All right, so the cosine of 45 degrees, square root of 2 over 2. The cosine of 30 degrees, square root of 3 over 2, and those are being multiplied. Subtract. Sine of 45 degrees, square root of 2 over 2, times sine of 30 degrees is a half. And a lot of these answers are not going to come out rationally, so we don't really have to go to the calculator. These two, square root of 2 times square root of 3 is, can you all see this? Square root of 6 divided by 4, because 2 times 2 is 4. Subtract. Square root of 2 times 1 is square root of 2 over 4. And that's pretty much our answer. We can take it one more level and say that square root of 6 minus square root of 2 over 4. But that's it. That's all we can do. That is the exact value of the cosine of 45 degrees. Sorry, 75 degrees. And so just to prove that, let's see, we'll make a calculation. Making sure that I am in degree mode because we're calculating a degree. So if I did the cosine of 75, that's square root of 6 minus square root of 2 over 4. Yes, for those of you asking, I know who you are. You're going to have to show your work. Yep. Happy April Fool's Day. Can't just use your calculator. All right. Next problem. Let's find the exact value of sine 135 degrees. All right, so just so everybody can see it, I'm going to write the function, the identity, sine of u plus minus v equals sine of u cosine of v plus minus cosine u sine v. Just so we have that up there. All right, so now we have to come up with a value of 135 degrees. So you look at the unit circle, 135 negative. Okay. If I take 180 and 45, 180 and 45, and I want a negative angle, remember, 45 minus 180 is negative 135 degrees, which is exactly the value we're looking for. Again, there's many ways you can come up with that. That's just the one that I came up with real quick. So here and here. Those are the two sets of values that we'll be using in this problem. So sine, and we want it negative, so it's 45 minus 180. So that makes the 45 become the u, and the 180 become the v. So if we're trying to match this to our identity, u is first, v is second, so 45 becomes u, 180 becomes v. Okay, so kind of ran out of room here. So it's going to be sine of 45 cosine 180. All right, let's check this. Since we're doing a subtraction, we have subtractions on the bottom, so we'll use subtraction right there. Minus cosine 45 sine 180. Okay, unit circle, grab some values. That's going to be square root of 2 over 2 is the sine of 45. The cosine of 180, hard to see, that's why you need a better unit circle. That's the x value of 180, which is negative 1, minus cosine of 45, square root of 2 over 2. Sine of 180, need a good unit circle, is 0. So if you're quickly paying attention to this problem, you'll know that, well, 0 times anything is gone, and that subtraction sign is not going to mean anything, and so all we have is this right here. And so this probably wasn't the best problem to do, because somebody's already figured out that negative 135, well, that's about right here. And the sign of negative 135 it's right there, which matches exactly what we got. But we proved that you can do this using an identity versus just using the unit circle. All right, let's check out a tangent. Tangent of 165 degrees. Now, there is no 165 on here, so for those of you that were like, oh, well, there'll just be a negative 135, we can just steal. Nope, can't do that. 165. So how can we get 165? 165. Well, you can use 120 and 45 if you add them together. Okay, so we'll do that. Again, you may have seen something different. So, what were we doing? 120, and the 45 right here. So those are the two we're going to do. And that identity that you guys should have already written down, tangent of u plus minus v equals tangent u plus minus tangent v, all divided by 1 minus plus tangent u tangent v. Don't have to memorize these, you just have to have them written down so that you can find them when you need them. And so we're doing 165, so we're going to use 120 plus 45. So 120 is our u, 45 is our v. Gets a little bit trickier here with this problem. All right, so let's see. We're using plus. We're using plus in the formula in our calculation. So we use plus and we use minus. So plus on top and minus on bottom. All right. So tangent 120 plus the tangent of 45, all divided by 1 minus tangent 120 times tangent 45. So on the bottom, you have multiplication right here, where on the top you're adding them. Now, if you guys have your unit circle in your notebook, you probably have the tangents written around the outside, like we talked about earlier in the semester. See how convenient they're gonna help you out now, right? So the tangent of 120 is negative square root 3 over 3. That is not right, coach. How about just negative square root of 3? Y divided by x. Okay? See, that's why you have them written down. So tangent of 120 is negative square root of 3. Plus tangent of 45. Tangent of 45 is 1. Okay, on the bottom, 1 minus. It's multiplication now. Square root of 3 times 1. So it's the same two values that you used here. You just use them down at the bottom a little bit differently. And then it's just a matter of adding and kind of getting this set up. Let's get this in standard form. So these two are going to switch. So this is going to become 1 minus square root of 3 all over. Now on the bottom, you get a double negative. So that becomes positive 1 plus square root of 3. No, this does not cancel out. Nothing here cancels out. But you can't leave a radical on the bottom. So you have to use a conjugate. That is not right. So 1 minus square root of 3 over 1 minus square root of 3. Conjugate has a different sign on the bottom. So if this is plus, we use the minus here. Multiply top and the bottom by the same value. And you got to FOIL this out. 1 times 1 is 1. 1 times negative square root of 3. Negative square root of 3, and negative square root of 3 times negative square root of 3 is positive 3. On the bottom, if you remember conjugates, when you FOIL, the O and the I cancel. So really we only have to multiply the F. 1 times 1 is 1, and the L. Positive square root of 3 times negative square root of 3 is negative 3. Okay, clean this up one more time. We're done. So 1 plus 3 is 4. Negative 2 square roots of 3 all over negative 2. We do have a little simplification to do. Negative 2 will divide into both of those. So we get negative 2 plus square root 3. And there we are. That's finished. Yep, tangent problems are more of a pain in the butt than the sine and the cosine problems. But you won't have to do many of them. So hang tough. A lot of algebra that you're supposed to already know. All right, so let's change gears and look at a different type of problem. I do have some other examples that we're going to skip here. And we're going to move on. This is more of a right triangle trigonometry problem, where we're going to use a cosine sum to find the exact value. So if you read this, it tells you have two quadrant 1 triangles. So make sure you draw the triangle correctly. This is the alpha triangle. This is the beta triangle. And so sine is opposite over hypotenuse. So it puts a 5 here, a 13 here. And we talked about Pythagorean triples earlier in the semester. So hopefully you know that that's 12. Over here, cosine is adjacent over hypotenuse. So that puts 4 here, 5 here. That's also Pythagorean triple, which makes this side 3. So those Pythagorean triples just speed up your work for you. All right, cosine addition. So cosine addition, cosine cosine, sine sine with a subtraction in the middle. So we got cosine alpha cosine beta minus sine alpha sine beta. We have our alpha triangle, have our beta triangle, and that's where we're going to get our information to finish this problem. So the cosine of A right here, it's going to be 12 over 13. Cosine of beta, the beta triangle, it's going to be 4/5. Minus the sine of the alpha triangle, which is 5/13, times the sine of the beta triangle, which is 3/5. Okay, so this is something we can just plug and chug into the calculator, get a final answer. So that's going to be 12/13 times 4/5 minus 5/13 times 3/5. Boom. Get a fraction out of that. 33/65. So once we figured out the two triangles, it's just a plug and chug into the cosine sum identity, plug it in the calculator, whip it out, make it a fraction, done. Okay, not quite as fancy written, but same idea. You got an alpha triangle and a beta triangle. Both of them are quadrant 1s, quadrant 1 triangles. So make sure that you draw two quadrant 1 triangles. The tangent is opposite over adjacent. So the opposite side is 4, the adjacent side is 3, and that's a Pythagorean triple. So we're going to have a 5 as hypotenuse. Beta triangle, all right, cotangent. Be careful here. This is adjacent over opposite. Helps to know what your identities are. So the cotangent of beta, okay, so the adjacent side is 5, the opposite side is 12, which makes the hypotenuse 13. Same two basic triangles that we saw in the previous problem. All right, now we're doing sine subtraction. Okay, sine subtraction. Sine subtraction is sine cosine, cosine sine. We got subtraction in the middle. So sine of alpha cosine of beta minus cosine of alpha sine of beta. Okay, grab some numbers from grab some fractions from the two functions, to the two triangles up top. The sine of alpha is 4/5. Cosine of beta, 5 over 13. Subtract cosine of alpha, 4/5. 3/5. Adjacent over hypotenuse. And the sine of beta, 12 over 13. Calculator time. Plug and chug. Try to get this on there for you. You don't have to do the fancy fraction button. Just do the division sign. It's a little bit faster. make it a fraction. What is that? Negative 16/65. That is the sine of alpha minus beta using a couple of triangles. Yep, you got to show all your work, except you can plug in the calculator and let the calculator do all that calculation for you. But you got to set it all up, got to draw the triangles, and show me an answer. Alright, so this is supposed to be 35 over 37. Okay, again, quadrant 1 triangles. This is alpha, cosine. Cosine is 5 over 13. Missing side's 12. Cosine of beta. Let's make that a B. Is 35 over 37. Okay, here's a Pythagorean triple that's not quite as common. So 37 squared minus 35 squared is 144. Square root 12. Well, that's supposed to be 12. Okay, so we get another 12. So do a little Pythagorean theorem, triangle, and figure out what your missing side is. A little bit less common on that Pythagorean triple. Almost done. We'll get through this problem, finish this up. So we got tangent plus. So tangent alpha plus tangent beta divided by 1 minus tangent alpha, tangent beta. Alright, tangent of alpha. Here's the alpha triangle, 12 over 5. 12 over 5 plus tangent of beta, 12 over 35. 1 minus those same two fractions. This time they're just multiplied. And you can plug this in your calculator. Nice thing about these triangle problems, you can plug them in your calculator. You just got to be careful. Okay, make a fraction out of this one. Hopefully you can see that. Alright, so fraction on top of a fraction there. 12 over 5 plus 12 over 35. 1 minus fraction 12 fifths. Oops. Fraction 12. Oh, I just hit clear. Okay, let's try that again. Fraction 12 fifths plus 12 35th. 1 minus 12 fifths. Fraction 12 35th. Let's make that a 35. Okay, so that looks like what I've got written down. Maybe a little bit blurry on the screen, but is exactly what I wrote down. Hit enter. Boom, gave me a fraction. Sweet. So our answer is 480 over 31. And that's going to do it. That's the sum and difference identities. Highly, highly recommend you guys practice and ask questions. Alright, so you have a Delta Math assignment on these topics. There's 15 problems. Normally you have 2 days to do it. You do not have 2 days to do it because we have another lesson to do on Friday before spring break. And so you need to get this done. So you have until Friday at 2 p.m. So you have a little over a day to get this done. Good luck. Please ask questions. Have a good day.